The atmospheric pressure decreases with increasing altitude. At sea level, the average air pressure is 1 atmosphere, 1.099227 kilograms per square centimeter. The table shows the pressure P in atmosphere at selected altitude H in kilometers.
A. Use a graphing utility to find a model of the form P equals A plus B ln H for the data. The graphing utility we used was Wolfram Alpha, and the and the model of the form P A plus equals A plus B ln H that the page gave us was this equation 1.012. In this case, H is X and P is Y. So it will be equals to P and this to H. The graphing utility didn't work to find an exponential model, and a logarithmic model will be find an exponential model.
Okay, so now in letter B, it says use a graphing utility to find the logarithm model H equals A plus B ln P for the data. So what you need to do here is similar to what you did in the first step. But instead of plotting the points in H and P, you will plot them exponentially, meaning you will do P comma H. So you will, instead of having 0 comma 1, you will have 1 comma 0. And so like the next one will be 0.55 comma 5 and so on. And this way you plot it in the website and it will give you an answer, which is y minus 6.44738 log, and in parentheses 0.8747565x. And in this one it gives you in logarithms.
In letter C, use a graphing utility to plot the data and graph the model. You just need to plug this data as well as you prefer in the website or in the graph, and you will get the points in this graph and the equation of the graph.
D. Use the model to estimate the altitude when P equals to 0.75. To estimate the altitude, we're going to use the equation we got in letter B. This was the equation we got. We know that P equals to 0.75, so we're going to plug in the 0.75 in the P. And here is plotted now. Plug in, and calculating this equation in the calculator, we're going to get that H equals to 1.18, so on, and this is how we can estimate the altitude.
So in letter E, it says use the model to estimate the pressure when H equals 3. So what you need to do is, with the equation you got on the letter A, we will plug in h, that is 13, in here, in the exponent. And so you will have this. And once you multiply it on the calculator, the answer you will get is p equals 0.1757 and so on.
In problem F, use the models to find the rates of change of pressure when h equals 5 and h equals 20. Interpret the results. What you need to is to take the first equation that we get in problem A, which is this one, and find its derivative. So you need to get the derivative of the exponent that gives you negative 0.134589 and multiply it times the number, and then once you have the derivative, you need to plug in the 5 and the 20 in different equations. So your first answer with h equals 5 will give you p equals negative 0.069, and with 20 it will give you p equals negative 9.2202 times 10 to the negative 3.